Welcome to video lesson 8.5 on comparing linear, exponential, and quadratic functions. Alright, so basically what you're going to be doing today is not really learning anything new, but just reviewing all the different types of functions you've already learned and be able to take from either points on a graph or points in a table to be able to decide whether a function is linear, exponential, or quadratic. Okay. Just to review, a linear function is in the slope-intercept form, y equals mx plus b. It forms a straight line when graphed. Okay. An exponential function is in the form of y equals ab to the x, and that forms a curve. And a quadratic function is what we've been working on in chapter 8, and that forms a parabola, and it's in the form of y equals ax squared plus bx plus c. For example 1, we need to plot the points, and then we just have to say whether that's going to form a linear, exponential, or quadratic function. Alright, so first we need a graph. 4, 4, 2, 0, 0, 0, 1, negative half, and negative 2, 1, 2, 3, 4. Okay. And 1, negative half. I know what I graphed, sorry. I graphed 0, 0, that's right here, but 1, negative 1 half is down here, and we have something that looks like this, so that would be a parabola shape, so that is quadratic. Okay, so it's a quadratic function. 0, 1, 2, 4, 4, 7, 3, 4, 7, negative 2, negative 2, negative 4, 2, 3, 5. And it looks to me like that forms a straight line. So that is a linear function. And 0, 2, 2, 8, 1, 4, negative 1, 1, and negative 2, half. And this is looking like it's forming a curve, so this will be exponential. Alright. Now, this is just giving you some common differences and ratios of functions. Okay, just a chart. So, looking here, you can see to get from x to x with this linear function of y equals 2x plus 5, okay, we're adding 1 each time. And to get to the y's, we're adding 2. Okay, so the y values have a common difference of 2. Okay. And then the exponential function, y equals 4 times 2 to the x, we're adding 1 for the x's again. So as x increases 1, what happens to the y's? They're being multiplied by 2. Okay, so they have a common ratio of 2 being multiplied. In the quadratic function, okay, here we're also adding 1 to get from one x to the next. Okay, and when we're first looking at it, we're subtracting 1, adding 1, adding 3, then adding 5. But if we look at the second set of differences, okay, from here to here, all right, then we're adding 2, then we're adding 2 again, and we're adding 2 again. So this was the first differences, okay, which we didn't have to go this far with any of the other functions, but with the quadratic functions we are. And here are the second differences. And what we can see from this is that in a quadratic function, the second differences are constant, okay? Always changing by the constant thing. Okay? And now another example. We have to know from this table whether it's linear, exponential, or quadratic. Okay? So we're going to look at the relationship here. Again, x's are going up by 1. And what's happening to the y? Here by 3, by 3, by 3, by 3. So this is a common difference of -3 so this would be a linear function. Okay. Now here, the x's are going up by 1, and the y's, okay, let's take a look at what's happening. Going down by 1, going up by 3, going up by 7, going up by 11. Okay. Now since that happened, there's no pattern there, let's find the second differences. Okay, so from -1 to 3, we're going up 4, going up 4, going up 4. Since we had to look at the second differences and the second differences are constant, that means this is quadratic. Second differences are constant, so this is a quadratic function. Very good. All right, and one more example. Now we have a table, okay? Not only do we want to decide whether this is a linear, exponential, or quadratic function, we also want to write an equation using the correct form. Okay? If it's linear, it'll be slope-intercept form. If it's exponential, it'll be an exponential form. And if it's a parabola or a quadratic, it'll be in the parabola form. So, first step is basically to graph this data. Okay, so we'll kind of graph this, go up by 2's. All right, 0, 0. Maybe it's better if I use a different color here for graphing. So 0, 0, 2, 1, 4, 4, 6, 9, 8, 16. Okay. And we can see here this is kind of curved. Okay. So it's either going to be, since it's curved, it's either going to be exponential or quadratic. So now let's take a look at the y values and see the differences there. Okay. Because if it's has a common ratio, it'll be exponential. And if I have to find the second set of differences, then I know it will be quadratic. So to get from 0 to 1, I have to add 1. To get from 1 to 4, I'm adding 3. To get from 4 to 9, I'm adding 5. And 9 to 16, I'm adding 7. Okay, so we can see there it's not going to be exponential. And now from 1 to 3, okay, I'm adding 2. 3 to 5, 2, 5 to 7, 2. So since the second set of differences is constant, this is a quadratic function. Okay, and now we just have to figure out the equation. All right, so we have to use the form y equals ax squared since it's a quadratic function. Okay, and then what we need to do is just substitute in a point. Okay, so I'll just use the point 2, 1. Doesn't matter which point I use. Okay, so 1 equals a times 2 squared. So 1 equals a times 4, divided by 4. So a equals 1/4. And then rewrite the equation, 1/4 x squared. Okay, so this is a quadratic function, and the equation is y equals 1/4 x squared. All right. Now this is just a brief summary. Okay, a linear function, the form of a line that it's going to take, kind of if the values of m are greater than 0, if the values of m are less than 0. Quadratic function, okay, what that looks like, and exponential and quadratic. Okay, and now you have a couple practice problems here. Make sure you write down any questions that you had. Again, this is a little bit of a review lesson, but there still may be questions, so please jot them down and remember to ask them in class. Thank you. Have a great night.